Bonjour, Mr. Sutton here with the AB Calculus 4-6 Extra Practice Number 4 solutions on graphical analysis. For this problem, we're given the graph of f, and we want to figure out what f prime looks like. So one key feature that I notice on the f graph here is that we have an undefined spot, a vertical asymptote at x equals -3. So therefore, f prime should also be undefined at x equals -3, which means choice C can be eliminated. All right, so now let's look at the slope of f. So we are decreasing and then decreasing on this one. That means that f prime should be negative and negative before and after that discontinuity. So looking at our f prime graphs, A is negative, negative, B is positive, negative, so we can eliminate B. D is not negative at all. So by process of elimination, choice A. On this one, we're given the graph of f, and we want to figure out what f prime looks like. So key feature of f that I notice, we have vertical asymptotes. F is undefined at -4 and +4. Therefore, f prime will also be DNE, does not exist, at plus and -4. Looking at our answer choices, that eliminates choice D. Let's look at the slope of f now. So we are decreasing, decreasing, and then increasing, increasing. So that means that f prime is going to be negative, negative, then positive, positive. Looking at our graphs, A is positive in the beginning, so it can't be A. B is also positive too soon, so not B. C is negative, negative, then positive, positive. So C looks like the graph we're looking for. On this problem, I'm given the graph of f, and I want to figure out what f prime looks like. So one key feature here is that we have a plateau here at x equals 0. This is a place where the slope is 0. So f prime should have a slope of 0 at x equals 0. But unfortunately, looking at all the graphs, they all have that. So that doesn't really help us too much. Next thing to look at is the slopes. F is increasing followed by increasing, which means f prime should be positive followed by more positive. Looking at our graphs, A matches that description. B does not. It's negative then positive. C also has some negativity along with D, so then choice A is the only one that still works. For this problem, I'm given the graph of f prime, and I want to figure out what f could look like. So one thing I notice right away is that f prime does not exist at x equals negative and +4. That means that if nothing else, f is going to be non-differentiable at those two x values. So taking a look at our possible graphs of f, A can't be it because A looks like it's differentiable everywhere. B has some issues at negative and +4, so B could still be it, along with C and D. So this at least eliminates A. Now let's look at the sign of f prime, and that will tell us about the slope of f. So our signs here, we are negative, negative, and then positive, positive for f prime. That means that f itself is going to be decreasing, decreasing, followed by increasing, increasing. So looking at my graphs that are still in the running here, B is decreasing, decreasing, then increasing, increasing, so B works. C is increasing too early. D is decreasing, but then it's increasing, so by process of elimination, it's got to be B. For this problem, I'm given the graph of f prime, and I want to figure out what f looks like. So one key feature I always look for with f prime is x-intercepts, places where f prime is 0. It looks like there are two such places on the graph of f prime. That means that the graph of f should have two places where the slope is 0. And since f prime is changing sign at both of these spots, we should have two extrema for f, not just plateaus, but actual maxes or mins. So looking at all our candidates here, A doesn't have any extrema, neither does B. C has two of them, so C is still in the running. D appears to only have one extreme, so then it's got to be choice C. On this problem, I'm given f prime, and I want to figure out what the graph of f might possibly be. One key feature I notice is that f prime does not exist at x equals -1. That means that f will have a non-differentiable spot at x equals -1. So it looks like most of the graphs have a discontinuity at that spot, but choice A does not, so we can eliminate A. Next, looking at the sign of f prime, we go from positive to positive. That means that f is going to have increasing as its behavior. So looking at choice B, that one's decreasing initially, so that can't be it. C is increasing followed by increasing, so C looks good still. And then D is increasing but then decreasing. So the only one left then is choice C. For this one, we are given the graph of f, and we want to figure out what the graph of f double prime might look like. So the only feature that really counts if you're going from f to f double prime is concavity. We notice here that f is concave down for the whole function. That means that f double prime must be negative. So taking a look at the graphs here, choice A is negative everywhere, so that's a good candidate. B has some positivity along with C and D, so only choice A is going to work here. On this one, we're given the graph of f, and we want to figure out what the graph of f double prime could look like. So one thing that really counts going from f to f double prime is looking at the concavity. We notice that we are concave down, followed by up, followed by down on the graph of f. So that means that f double prime must be negative, then positive, then negative again. Looking at our answer choices, choice A, we're going negative, positive, negative, so that looks good. B does not follow that pattern. We start positive. Same thing with D, also starting positive. Choice C starts negative, but then it's negative again and positive, followed by more positive, so C doesn't quite match. So really, choice A is the only one that matches this perfectly. On this problem, I'm given the graph of f double prime, and I want to figure out what the graph of f might look like. So f double prime tells you about the concavity of f and not a whole lot else. So we notice here that f double prime is negative followed by positive. That means that f itself is going to be concave down followed by concave up. So looking at our answer choices, choice A is concave down then up, so A is good. B starts concave up, so that's no good. C is concave down then up, but then concave down again. Too many changes in concavity for choice C. And then D also has that issue of having 3 different concavity intervals versus just the 2. So really choice A is all that works here. For this free response problem, we're given a whole bunch of information here. They gave us a graph of G, and they also told us that we have this f function where f of 0 is negative 1, and we have the derivative of f given right here. We're going to need this for part A, in which they want us to find the x-coordinate for each critical point for f, and then classify each of those as a min, a max, or neither. So to find critical values for f prime, we need to figure out where this is either 0 or undefined, and since it's a combination of a polynomial and an exponential, it's defined everywhere, so it's really just going to come down to where this equals 0. So setting that equal to 0, I have 2 factors here. For the first factor, x squared minus 5/4, that's going to equal 0. If I add 5 over 4 and square root it, that's going to give me plus or minus radical 5 over 2. So that's 2 critical values. And then for e to the x, if you try to set that equal to 0, you're in for some disappointment because it's an exponential, which means it's always going to be positive no matter what. So there's no way it's ever going to equal 0. So then we just have 2 critical values, plus and minus radical 5 over 2. To see if those are mins or maxes, we can just do some sign analysis on a number line. So this is f prime right here. We've got negative radical 5 over 2 and the positive version of that. And I'm just going to test a number in each of these different intervals. So a number less than negative radical 5 over 2, well, how about negative 2? That's a little bit less than that. So if I plug in negative 2, e to the x is always going to be positive, so I don't have to worry about that. But this x squared minus 5/4 could come out negative or positive. If I plug in negative 2, that's going to be 4 minus 5 over 4, which comes out positive. And now something between these critical values, well, we can try out 0. That's going to give me 0 minus 5/4, which is negative. And then if I plug in something bigger than root 5 over 2, like 2, that's going to give us 4 minus 5/4 again, which is still positive. Now I notice that f prime is changing from positive to negative at x equals negative radical 5 over 2. Therefore, we know that f has a relative max at that x value. And we also notice that f prime is changing from negative to positive at root 5 over 2, positive root 5 over 2. Therefore, f is going to have a relative minimum at x equals radical 5 over 2. On this problem, this part of the problem, I want to find all x values where the graph of f has a point of inflection and give reasons. So this is going to be wherever f double prime changes sign. So we're going to start by figuring out what f double prime actually looks like and get some critical values out of it. Here's f prime. So taking the derivative of this is going to require the product rule. Let me set up my box and ribbon here, and I'm following the form of u prime v plus uv prime. So I've got my u and my v up here. That's the two factors, x squared minus 5/4 and e to the x. And down here I've got u prime and v prime, the derivatives. So this one down here is going to be 2x, and this other one is going to be e to the x. So using the ribbon to multiply this out, we've got 2x e to the x plus parentheses x squared minus 5/4 times e to the x. And we're going to set this thing equal to 0 and find some critical values. Now, just like with the first derivative, we don't have to worry about this thing being undefined because it's made up of all continuous functions. So solving this, equaling this to 0, one thing we can do right away is pull out an e to the x. That's a common factor. Now, normally I would just pull out an e to the x in this situation, but if I do that, I'm going to end up with a negative x squared inside, and I'm thinking I'm probably going to have to end up factoring a quadratic at the end of the day on this one, and I'd rather have a positive x squared to do that. So I'm actually going to pull out a negative e to the x at this point. If I do that, then I can write inside of parentheses positive x squared. This will now be a negative 2x, and this ends up being a negative 5/4 because I'm getting rid of this negative out here that would have switched the sign. Okay, well, now I've still got to factor this, so that's going to be a little bit weird because we've got this fraction over here. But one thing we can do, I mean, we're trying to find two numbers that multiply to negative 5/4 and add up to negative 2. Well, I mean, 5, there's only one way to get that. You need a 1 and a 5. And to get 4, I mean, you could have a 1 and a 4, but it's probably more likely that you have 2's down here. So how about 1/2 and 5/2? That would multiply to give me 5/4. So if I do that, which one's got to be positive and which one's got to be negative? When we do the inners plus the outers and add them together, we get a negative 2x in the middle. So I'm thinking the bigger absolute valued one has to be the negative one. So I'm thinking x minus 5/2 and x plus 5/2. Let's write it out and just double check it. So this is going to be negative 5/2 x plus 1/2 x. That's going to be negative 4 over 2x, which is negative 2x. So that actually works. Cool. Well, that means our critical values are going to be negative 1/2 and positive 5/2. So that gives us two things to put on an f double prime number line and do some sign analysis with. So I'm going to do that sign analysis down here because I've kind of run out of space up here. So there's my number line. This is an f double prime line. I've got to label it. I had an f prime line on part A, so it's good that I'm labeling these so people know what I'm actually doing here. I've got critical values at negative 1/2 and positive 5/2, and now testing something in each interval. Something to the left of negative 1/2, that would be negative 1 is a good choice. So plugging that in up here. Now, as you're doing your sign analysis on this factored version of f double prime, this negative e to the x is always going to come out negative because e to the x by itself would normally always come out positive. So we have a guaranteed negative out here. So, and then we've got whatever happens with these parentheses. So we've got a negative, another negative if you plug in negative 1, and then this is going to be another negative. 3 negatives gives us overall a negative result. Now let's test something between these two critical values. 0 is a good number. So we've got a negative, a positive, and another negative. 2 negatives gives me a positive. And then something bigger than 5/2. How about 3? So that's going to be negative, positive, positive. So 1 negative gives us negative overall result. Now, the important thing here is, again, we were looking for sign changes in f double prime. In terms of justifying what we're about to do here, we can say that f double prime changes sign at x equals -1/2 and x equals 5/2. Therefore, f has a point of inflection at both of those x values. On this problem, the g function is finally going to get some attention. We've got a table with some missing entries on the x values from -3 to 3. They just want us to plug in positive or negative for each of these missing spots, but they also want reasons for the answers. So let's take a look at g prime, missing a few indicators between -3 to 0 and from 0 to 3. Now g prime is talking about the slope of the g graph. And g, we notice, is increasing on the whole interval from -3 to +3. Therefore, g prime is going to be positive across that whole interval. So we can put positive and positive in both of those intervals. Okay, now we're talking about g double prime. That's talking about the concavity of the g function. Now looking back here, we notice that g is concave up from -3 to 0. That means that g double prime is going to be positive on that interval. So let's indicate that down here in the table. We also notice that g is concave down from 0 to 3, which means that g double prime is going to be negative on the interval from 0 to 3. So that means we'll put negative in that part of the table, and we're done with that one. For this last part of the problem, we're defining a new function h as f of x times g of x, and we just want to know if h is increasing or decreasing at x equals 0. Well, let's talk about h prime first. So because this is the product of f and g, we're going to use the product rule. I can say that h prime of 0 is going to be f prime of 0 times g plus f of 0 times g prime of 0. And then we just have to figure out what each of these things are. Basically, we want to know if h prime is positive or negative, because that's going to tell us if h is increasing or decreasing. So looking at each of these individually, f prime of 0, if you plug 0 into the f prime function here, that's going to be -5/4 times, let's see, e to the 0 is 1, so overall just -5/4, and that's a negative number. Now g of 0 we can look up in the table. G of 0 is just 2, and that is a positive number. Over here, f of 0, well, f of 0, what's that going to be? Oh, they told us. It's -1, and that's a negative number. And then finally, for g prime of 0, well, we notice that g is increasing at the x value 0. Therefore, g prime of 0 is going to be positive. We don't know exactly what it is, but we know it's positive. So we've got, for this first term, a negative times a positive, which is a negative. For the second term, we have a negative times a positive, which is also a negative. If you take two negatives and add them together, you get something that is negative. Therefore, h prime of 0 must be a negative number, which means that h itself must be decreasing at x equals 0.